recording. Okay, last lecture we have seen graph of y is equal to sine 1 upon x, and we said that this limit does not exist at x is equal to 0. We have proved it also by taking epsilon is equal to 0.2. Then we dampened effect of vibrations by multiplying by x, and then this kind of graph is achieved, and we said okay, because of this x, now the limits started existing, and if you happen to define the function is equal to 0 at x is equal to 0, then we found that function to be continuous because left and right hand limit was 0, and the function value of the function at x is equal to 0 also was 0. Now we further dampen it by multiplying by x square. So if we try to sketch y is equal to x square sine 1 upon x, the graph will be enveloped by y is equal to x square and y is equal to minus x square. Vibrations because of sine 1 upon x will continue to be there. However, they will not cross this boundary. Y is equal to x square and y is equal to minus x square. As a result, as you tend to 0, as you move towards 0 from left hand side and right hand side, the vibrations, the amplitude of the vibrations will become smaller and smaller, and therefore you will achieve continuity near 0 if you define the function equal to 0 when x is equal to 0. Continuity can be achieved, which can algebraically proved like this. Limit x square sine 1 upon x is equal to limit x into sine 1 upon 1 upon x as x tends to 0. Now there is a mistake which students do. The second limit that we have here, they say that this is 1, but it is not 1, it is 0, because x is tending to 0. That means denominator is tending to either plus infinity or minus infinity, depending upon whether you are approaching 0 from right side or left side, and numerator is bounded between minus 1 to 1. So a finite number in the numerator divided by a big positive number or a negative number in the denominator will produce value of the function equal to 0. So 0 into 0 becomes 0, and if you happen to define y is equal to 0, if x is equal to 0, then we achieve continuity. So having said so, we now wish to discuss the differentiability of these functions. First, okay, discuss differentiability of 1, y is equal to sine 1 upon x, 2, y is equal to x sine 1 upon x, and 3, y is equal to x square sine 1 upon x. Okay, and now why we are stopping at this point? Because we know if we keep multiplying by x, we are going to get similar results. So results will not be similar for these three cases. Therefore, we are discussing these three cases. Okay, I give you time. You come out with the answer, then we'll discuss differentiability of these three functions. Okay. Correction, discuss differentiability of these functions at x is equal to 0. Algebraically, if we are checking differentiability, we need to rely on the definition of derivative. Check whether it exists and is finite or not. So we will continue all three functions with, we will subject all these three functions to the definition of differentiability. First one, limit x tends to 0, f of x minus f of c. So sine 1 upon x minus sine 1 upon 0 upon x minus 0. काय होणार आहे याचं, या लिमिटचं? What will happen to this limit? Will it exist or will it not exist? Anyway, we know that it does not exist, because anyway you are dividing by x, and this anyway is undefined. So does not exist. Second, so there is no question of first function being differentiable. And we, even if we do not write this, it is not going to be differentiable because limit does not exist in the first place. We need to have limit, we need to have continuity, then there is a chance of differentiability. Okay, function 2, limit x tends to 0, x sine 1 upon x minus 0 upon x minus 0. Okay, so what is happening here is this 0 is getting cancelled, this x is again cancelling this, and eventually we ended up checking limit x tends to 0 sine 1 upon x, which we know does not exist. So differentiability at x is equal to 0 of second function is also not available. Let us check with third. Limit as x tends to 0, x square sine 1 upon x minus 0 upon x, which is equal to limit x tends to 0, x sine 1 upon x. And this exists and is equal to 0. We have proved it just now. Now, whether you define the function at x is equal to 0 or not, if you define the function equal to 0 at x is equal to 0 or not, you will have differentiability at that point. Is this statement correct?
No, sir, because our definition for the differentiable is f of x minus f of c upon x minus c, right? So f of 0 has to be some number in order to use it.
Yes. So we have to have that f of c over there, and that definition must be such that y is equal to x sine 1, x square sine 1 upon x if x is not equal to 0, and equal to 0 if x is equal to 0. This is necessary condition. Otherwise, in other way, we can contradict our statement by saying that if continuity is not there, there is no question of differentiability. Continuity will fail if we don't define y is equal to 0 at x is not equal, x is equal to 0. Continuity will fail, and if we don't have continuity, we will not have difference, because continuity implies differentiability. Sorry, ulta na? Differentiability implies continuity. Recorded. Okay. Differentiability implies continuity. So we need to have value of the function f of c is equal to 0. Then only this cancellation will take place. If that c is something else here instead of 0, then we are in trouble. Therefore, it has to be defined, and then we get this function differentiable. Okay. So therefore, this function is very, very important, and this is a basic function sine 1 upon x with vibrations and two dampening effects. Two dampening effects, y is equal to x, dampens it with straight lines, and y is equal to x square with the curvature. Okay. Now, as such, there will not be any problems related to this, whatever we have discussed. But this sine 1 upon x function can be present in some of the problems where you need to know in and out about this function and deal with the composition function where sine 1 upon x is involved. Okay, therefore it is important. Okay, the next function that we, we will discuss is Dirichlet. कुठेतरी मध्ये आयच्या ऐवजी ई असण्याची शक्यता आहे स्पेलिंग मध्ये, पण डिरिचलेट फंक्शन इज अ फेमस फंक्शन. y इज इक्वल टू, आता का घेतोय मला माहित नाही पण घेतो चला, y इज इक्वल टू 1 इफ x बिलोंग्स टू rational numbers, is equal to 0 if x belongs to irrational. I mean, I can flip them also. Y is equal to 0 if x is rational, y is equal to 1 if x is irrational. Now, can you sketch this? Sketch and discuss continuity. Sketch and discuss continuity of Dirichlet. बघा आता अजून एक मला चला दाखवा, मला ग्राफ तुम्ही काढलाय, दाखवा. शो मी द ग्राफ ऑफ Dirichlet. Okay, the graph of this function, बघूया, we will discuss that. The graph of this function is going to be like this: x-axis, y-axis. Now, if I happen to find rational number, I should have point on y is equal to 1. But then these rational numbers are also so dense that practically it will be a straight line. And irrational numbers are also so dense that practically it will also be a straight line. हा, आता काय म्हणायचं तुला, इथे आलो पाहिजे असं म्हणायचं का, x इज इक्वल टू 0 सगळ्या इंटिजर्सनाच का, अरे कुठची हलो पाहिजे, लोअर की अप्पर, लोअर, आणि अप्परला either it has to be completely hollow line or it is completely dark line as far as sketching is concerned. That is why this function is important. I mean, our intuition about continuity is something else. Here, practically, you will not be able to sketch this function. And if you decide, if you have a courage to sketch this function, I mean, you end up drawing two parallel lines. Then two parallel lines parallel to x-axis destroys your intuition about function itself. Vertical line test, gone. Because they are two parallel lines. Practically, on vertical line test, function definition will be satisfied, because if that line has a point on lower line, then it does not have it on the upper line. लक्षात घ्या. पण density of number line is making us draw continuous lines at both the places, y is equal to 1 as well as y is equal to 0. त्यामुळे if you don't say that this is the definition of this function, and if you draw two horizontal lines, show the graph to someone else will say that this is not the function. This cannot be the function, because graphically vertical line test is not passing. But when you give the algebraic representation of this function, it of course is a very good function and it helps us. So that is why this is a special function, Dirichlet function. And the speciality of this function is, what is the speciality? It is discontinuous everywhere. It is not continuous at any point on x-axis. Discontinuous everywhere. Why? Because the moment you say that left hand limit and right hand limit is same, you will end up finding points which are irrational or rational, where the value of the function is not going to be desired value 0 or 1. Therefore, this function is discontinuous everywhere. That is why it is special. Okay. So then Dirichlet came with some modification in this function. So this is first version of the Dirichlet function. Second version of the Dirichlet function is y is equal to x if x is rational and is equal to 0 if x is irrational. Discuss continuity of this function. Sketch and discuss. Okay, for second question, the answer is not, discontinuous everywhere except x is equal to 0. Okay, why near 0 you will end up getting the continuity? Limit x tends to 0, y. Now value of the function, if you have rational numbers in the delta neighborhood of 0, if you have rational numbers in the delta neighborhood of 0, the value of the function is going to be x. So in the delta neighborhood, their value is going to be whatever they are, value of the function. And they are anyway near 0, therefore value is going to be very, very small. Near, for all practical purposes, it will be tending to 0, that value. And if you have considered x as irrational number, anyway it is 0. Therefore, this limit is going to exist and is going to be 0. Because if you consider number in the delta neighborhood, it will tend to 0. If you consider irrational number in the delta neighborhood, it will tend to 0. Therefore, from both sides, positive as well as negative side, near x is equal to 0, you will have this limit and its value will be equal to 0. Anyway, value of the function at x is equal to 0 is again 0. F of c is 0 and therefore continuity at x is equal to 0. However, if you consider any other point on x-axis, you have the same problem that of problem number 1 and therefore it is discontinuous at all other points. Now, third version. Third version of this problem is y is equal to 1 upon q if x belongs to rational numbers and x is equal to p by q, where p comma q are coprimes. Q is greater than 0 and q is integer. P and Q, both of them are integer. right? And is equal to 0 if x does not belong to q, or f belongs to q dash. That is irrational. Now think about this, write down whatever you want to say, try to sketch and figure out the continuity. Discuss continuity. The question is discuss continuity. Okay, answer for third is not continuous at rational points but continuous at irrational points. Let me write down the answer. Not continuous at rationals but continuous at irrational. So now you search for the justification. Okay, Sahil is saying if, sorry, let C be irrational, because we are supposed to prove that it is continuous at irrational points. Let C belong to irrational numbers. Okay. So f of C is equal to 0. Right? आता तुला काय म्हणायचं आहे की in the delta neighborhood of C there will be rational points. So a rational point P by Q, will tend to C. Barabar? So rational will go near C, which is irrational. Therefore, what you are saying is इथे equality नहीं है, by the way. P by Q is not equal to C, but P by Q, okay, we can write this as P by Q minus C is equal to is less than delta. आता काय म्हणतोस तू?
1 by Q tends to C by Q.
1 by Q minus C by Q dividing everything C by P. Sorry. 1 by Q minus C by P. So dividing everything by P, and suppose P is positive. If P is positive, is less than delta by P. ठीक है? पुढे
C is irrational and P is integer, so C by P is also irrational.
Okay. C by P is irrational. Therefore, value of the function at that point is going to be 0.
Limit 0. Limit 0 is something continuous. Limit is equal to f.
थोडंसं काहीतरी त्याच्यात वाटतंय मला की अजून लागणार. लेट मी एक्सप्लेन इट टू यू. I mean the Dirichlet way. Let us consider an irrational number, say root 2. Let irrational number C is equal to root 2. Now root 2 can be caught between two rationals, because essentially we are supposed to prove that 1 upon Q will tend to 0. Okay, so I can catch root 2 1.4141 is less than root 2 is less than 1.41422, and I can increase these decimal points whatever limit I want 100 digits after a decimal point, I can have it, because anyway it is irrational number. So you can always have two rationals, one less than root 2, another greater than root 2. And now suppose, let us assume, because definitely we will be able to find out a rational such that it looks like this. 1 2 3 4 paths is less than root 2 is less than 141422 upon 1000000. Now you will say that this is not, they are not co-primes, but it is fine. They are also, they might be co-prime, they might not be co-prime. No, 5 and 2 आहेत ना, these are co-primes and these are not. So maybe we can make it 3 here and 3 here so that they are primes, co-primes. Is that okay? Root 2 will be caught between two rational numbers like this, and you can increase the numerator, whatever you want, corresponding denominator will be increased. So if you consider this irrational number in the neighborhood of root 2, the value of the function f of this is going to be equal to, approximately equal to 1 upon how much? 500, 1 lakh. And approximately, if you consider f of this, what will be the value of the function? 1 upon 1 lakh. But 1 upon 1 lakh is not 0, but it is definitely tending to 0. And this will be the case for every rational number in the delta neighborhood of irrational number. Okay. So therefore, in this case, to the left and right of root 2, to the left the value of the function is 1 upon 1000000, which is tending to 0. Therefore, f of x, limit f of x as x tends to 0 minus is equal to limit f of x as x tends to 0 plus is equal to f of 0. No, sorry, limit f of x as x tends to root 2 minus. As x tends to root 2 plus is equal to value of the function at f of x at root 2, which is equal to 0, hence continuous. Okay, so this is what is fabricated function, non-standard. And we can always write down proof in terms of epsilon delta. In this case, I am making it look complete bold. Okay, solve this numerical problem. N tends to infinity plus infinity. 3 raised to n minus 6 raised to n upon what? 4 raised to n plus 1 plus 6 raised to n plus 1. सांगा लिमिट किती येते? Divide numerator and denominator by largest infinity. Largest infinity term in the given 4 terms is 6 raised to n plus 2. So divide everything by 6 raised to n plus 2. And you will realize that these brackets are less than 1. Therefore, they will tend to 0. And hence limit will be minus 1 by 36. Okay, so now what we will do is, before getting into properties of continuous functions, we would like to complete our evaluation of limit so that I can say limit topic is over. So what is important in evaluation of limit is essentially the indeterminate forms, limits of indeterminate forms. Now, indeterminate forms we have seen 0 upon 0, we really do not know how to go about it. Like that, combinations of 0 plus infinity minus infinity, combinations of 0 plus infinity minus infinity, maybe 1 dynamic plus or minus near 1. So different combinations of these will produce indeterminate form. Say for example, 1, 0 upon 0 is indeterminate form. We do not know what do we do with that. Like that, if we permute all these and try to check, is it indeterminate or not? Second, is 0 into 0 indeterminate? Is 0 into 0 indeterminate?
No, sir.
No, 0 into 0 is 0. Annihilation theorem. Whether second fellow is 0 or not, 0 into everything is 0. So this is not indeterminate, this is equal to 0. We know that. But this is indeterminate. Okay. So can you come up with different permutations of these, and then we decide which are indeterminate, which are not. And then we will deal with only those many forms of indeterminate terms. Third, मी लिहू का पटापट आणि मग then you tell me whether this is indeterminate or not. 0 plus 0, fourth, 0 minus 0, fifth, plus infinity plus infinity, sixth, plus infinity plus minus infinity, seventh, minus infinity plus minus infinity. आणखी कोड राहिला आता ते सेमच आहे, कम्युटेटिव्ह असल्यामुळे. ठीक आहे. त्याच्यानंतर 8 झाला, 9th, 0 into 0 लिहिला, 0 into plus infinity, 10, 0 into minus infinity, 11, infinity plus infinity into plus infinity, 12, plus infinity into minus infinity, 13, minus infinity into minus infinity, 3, 14, 0 upon infinity. In 15, infinity upon infinity. Now again there could be, let me write all of them, plus plus. 16, 0 upon minus infinity. 17, minus infinity upon plus infinity. 18, minus infinity upon minus infinity. काही काही सोपे आहेत पण तरी लिहू सगळे. 0 upon infinity झाला, 0 upon minus infinity. पुढे infinity upon 0. 19, plus infinity upon 0. 20, minus infinity upon 0. 21, 0 raised to 0. 22, 0 raised to plus infinity. 23, 0 raised to minus infinity. 24, भरपूर आहेत लिहिलेले माझ्याकडे. 25, 24 लिहायचं आहे ना. 1 raised to 0. 25, 1 raised to plus infinity. 0 raised to infinity लिहिला. आता infinity raised to 0. 26, infinity raised to 0. मे बी पॉझिटिव्ह इन्फिनिटी राहील. अजून तुम्हाला काय सुचत असलं तर सांगा. माझे ते सगळे लिहून झाले. स्क्रीन दाखवा. रेकॉर्डिंग थांबवतो जरा. लिहून 0 plus 0. 0 into 0 we said is equal to 0. 0 plus 0 is also known to be 0. So it is not integer. 0 minus 0 is also going to be 0. Not integer. What about 5? Plus infinity plus infinity. Plus infinity. What do you think? Plus infinity minus infinity.
Indeterminate form.
Indeterminate. We just cannot say anything about it. Therefore, it has to be considered as integer. Minus infinity, minus infinity. Minus infinity. Plus infinity upon 0.
Indeterminate.
Is it indeterminate? If it is plus infinity upon 0, let us discuss this now. Plus infinity upon 0. Plus infinity upon 0. Now we have to consider two cases, whether you are approaching 0 from positive side or you are approaching 0 from negative side. Right? So for all practical purposes, maybe technically what am I saying is not correct, but plus infinity, I can take reciprocal. Denominator is tending to 0 plus, that means it is also plus like this. Instead of 1 upon 0 plus, I can write it as plus infinity. बघा समजतंय का? 1 upon 0 plus. What will happen? 1 upon 0 plus will be plus infinity. So plus infinity into plus infinity, we have to answer 11 first. What do you think? Plus infinity into plus infinity. Both the numbers are big numbers and they are positive numbers, it is going to go to plus infinity. Therefore, this answer will tend to plus infinity. However, if denominator approaching 0 from negative side, this ratio 1 upon negative infinity, negative 0 is going to be negatively signed, but big number. So this is for all practical purposes, this is going to be plus infinity into minus infinity, which we can deal with as 1 into minus 1. We can take out those two guys out, infinity into infinity. So infinity into infinity, we know infinity, and there is a minus sign outside. Therefore, plus infinity into minus infinity would become minus infinity. नाही, ॲझ्युम काहीच केलेलं नाही आपण, इथे काही इव्हॅल्युएट पण करत नाहीये. 1 अपॉन समथिंग टेंडिंग टू 0 प्लस. नाही, हे सगळे टेंडिंगच आहेत. इनडिटर्मिनंट फॉर्म्स जे आहेत, व्हेन यू आर इव्हॅल्युएटिंग द लिमिट as x tends to c, something in the numerator upon something in the denominator, if you substitute x is equal to c in the numerator, it will become 0. Denominator, it will become 0. Therefore, we are calling it as determinant form. Is actually numerator going to become 0? No, because x is tending to c, it is not equal to c. त्यामुळे हे सगळे जे आहेत इथे लिहिलेले 25, 26 च्या 26, all 26, they are tending to that. They are not actually equal to that. Okay, and therefore plus infinity upon 0 is not indeterminate. Similarly, minus infinity upon 0 is also not indeterminate. Tell me, अच्छा इकडून इकडे जायला पाहिजे होतं. ठीक आहे, 0 into plus infinity. 0 into plus infinity, I can visualize it as 0 upon 0 plus, and hence it is indeterminate. बघा समजतंय का? Simple. This is indeterminate. And you can always take a p 9 to 1. You can always take a p 9 to 1 by putting it in the denominator. 0 into minus infinity, I can write it as 0 upon 0 minus. So it is indeterminate. So we don't consider them to be two different cases. Let me just make it right now, and then we will list how many indeterminate forms we have. Plus infinity, झालं 13 is going to be plus infinity. बरोबर आहे. 14 कुठे गेला? हा, 0 upon plus infinity is 0 into 0. बरोबर आहे. So this will be equal to 0. Infinity upon infinity. Indeterminate, because you can visualize it as 0 upon 0 again by taking reciprocals. So 15 is going to be indeterminate. Okay. 0 raised to 0 is 0. 0 raised to plus infinity, danger. 0 raised to plus infinity, we really cannot predict anything about it. Zero raised to 0 1 असतं. 1 की 0? 0 raised to 0 indeterminate. चांगला विचारलास प्रश्न तू. 0 raised to 0 is not really sure, because if we say 0 by looking at the base of the index, then we are in trouble. If we say 1 by looking at index power of the index of this number, then also we are in trouble. Therefore 21 is also indeterminate. 0 raised to 0 आपलं होतं ना लिमिट, f of x tends to g of x आपण केलं ऑलरेडी as x tends to c 0 raised to 0 केलं ना ऑलरेडी लिमिट काढलं तर नाहीच लॉग घ्यायचा बरं ठीक आहे बघूया 23 0 raised to infinity 0 raised to plus infinity ला जे होणार आहे ते 0 raised to minus infinity ला now 1 raised to 0 1 anything 1 raised to 0 means you are tending to 1 and the power is 0 therefore it will be equal to 1 now 1 raised to plus infinity you are tending and the power is plus infinity indeterminate now this 21 चा अजून एक जस्टिफिकेशन देता येईल की h असं f of x raised to g of x is equal to y suppose तर this is tending to 0 this is tending to 0 so log y if we take we get g of x log f of x बरोबर आहे now g of x is still tending to 0 and log f of x is tending to minus infinity बरोबर त्यामुळे this is tending to 0 this is tending to minus infinity into minus infinity ला आपण डील केलं होतं that is as good as 0 upon minus 0 हे बघा 10 number 0 upon minus 0 and it is 0 upon 0 so indeterminate therefore 0 raised to 0 is indeterminate sorry मी चुकून ते 0 म्हणालो पण it is indeterminate 25th this is dynamic one otherwise 1 raised to anything is 1 but this is dynamic one like our e which we have found out 1 plus 1 upon x raised to 1 plus small raised to big x tends to infinity 1 plus small raised to big so in this case this is not 1 this is tending to 1 this bracket so it is of this form 25th and this is indeterminate 25th is indeterminate and 26th
Why can't we say 25th is 1?
why can't
it be 1?
because it is not this base of this term is not equal to 1 dynamic one it is little less than 1 or little more than 1 like this so if it is little more than 1 then raised to plus infinity will diverge it will become huge quantity but if this one is little less than 1 then it will tend to 0 by taking a higher power so if this one was 1 and not dynamic one then the answer would have been 1 but this one is not the constant one but it is dynamic one so 1 plus small or 1 minus small kind of one this is that makes it indeterminate नाही याचं उत्तर ई आहे असं असेल तर प्रत्येक वेळेलाच असेल असं नाही अरे हा जर 1 या फॉर्म मध्ये असेल तर हो वेगळा काहीतरी असेल इथे 2/x असेल तर तो ई कसं राहील वेगळं होणार ना आपण 2 इथे करायला लागेल रेस टू 1/2 करायला लागेल हे उत्तर येईल ई कसं होईल ओके एंड 26 के बारे में आपका क्या ख्याल है 0 into f of x log g of x okay again f of x is 0 and log g of x log of is tending to plus infinity therefore this is multiplied by infinity so this is 0 upon 0 so this is also indeed so there are many amongst the 26 that we have listed are indeterminate, but few of them are looking alike. So I will create a list of indeterminate forms which you should remember. 1, 2, 3, 4, 5, 6, and 7. There are total 7. 1. This is the list of indeterminate forms. Any problem where you find difficulty in evaluating the limit, it will be one of these. 0 upon 0. Second, infinity upon infinity. I take care of both positive, negative. 3, infinity minus infinity. In this case, both of them are positive. 4, 0 raised to 0, dynamic. 5, 1 raised to 0. 6, infinity raised to 0. And 7, 0 into infinity. These are the 7 indeterminate forms.
So instead of 1 raised to 0, it should be 0 raised to infinity, right?
No, 0 raised to 0 is there. Sorry, this is not 1 raised to 0. It is 1 raised to infinity. Mistake while writing. 1 raised to 0 is going to be equal to 1. We have written it here. 24th is not indeterminate form, but 25th is indeterminate.
Sir, can you please scroll up for a minute?
Huh?
Sir,
Can
16,
you
17,
scroll up
18.
for a minute?
16 काय 16
16, 17 आणि 18.
अच्छा डिस्कस राहिले का करायचे ओके 16 is 0 upon minus infinity which is 0 into minus 0 0 into opposite of 0 if you take that minus infinity up it is 0 into 0 therefore 0 minus infinity upon infinity is indeterminate because minus 1 times it is infinity upon infinity. This is plus 1 upon infinity upon infinity. So both of them are indeterminate. But they fall in this 2. 2 takes care of all of them. Okay, so that is where we stop and I will give you techniques to deal with these indeterminate forms so that you should be able to evaluate all possible limits if they exist. Okay, I stop recording.